can hear you and I can see your screen.
Okay, so shall I start?
Right ahead.
Okay. So basically, I guess if I can summarize the message in a nutshell in terms of YottaDB, the, the bad news is that the good news is that we didn't crash and burn. The bad news is that we didn't take off like a rocket. So we're kind of, chugging away and making steady progress every year. So first, let me talk about Sam. Were you saying something? No. Okay, I guess not. Um, so basically, first I'll talk about the YottaDB database, which is the core of our work. And this is the obligatory marketing slide about YottaDB. And these are the platforms on which it currently runs. So we support 3 CPU architectures. There's the x86-64, there's the 64-bit ARM, and then there's the 32-bit ARM, the Raspberry Pi Zero. And then on all platforms, Debian is supported, but then on x86-64, we have a bunch of different Linux distributions that we support. So in the last year, so excuse the somewhere out here I made a screw up with my screen, but it automatically just switches. But anyway, so we have 2 releases over the last year. So the first one was 1.36 in December 2022. And the main thing here is that, from a platform point of view, SUSE Linux is now fully supported. And then we've also been working on making things like diagnostics and troubleshooting and forensics easier and simpler. So, for example, there's a %proc stuck exec for catching stuck processes and various things like that. And then we've also made some programming easier, such as the ability to, when a global directory has changed, to load the changed global directory and so on. And then we also continue to remain compatible with the upstream GTM, and we have GTM code merges from 6.3, 12, 13, and 14. And then we, in March of this year, we introduced our 1.38, which was basically minor enhancements needed by a customer. So one of the reasons why someone might want to actually be a customer rather than a user is that we can then, we might then prioritize things that you need, fixes that you want, and so on. So we had a major customer that wanted a change to the way, an option to change what gets replicated. So we did that. And we've also significantly enhanced the YDB install script. So it pretty much handles all software installation and plugin updates. And since the plugins are continuously updated, you can specifically install an update without installing YottaDB itself. And there is now a GUI option to install the GUI. And other minor enhancements. So Rocky Linux, if you're running on Rocky Linux, it'll recognize that and use the Red Hat installation. For OpenSUSE Leap, it uses the SUSE Linux enterprise distribution. And there's also a %YDB journal to analyze journal files, and I'll be talking about that later today. So we continue to remain compatible with the upstream, and as they put out releases, we take those releases, we test them, we merge them with our source code, we make our own enhancements and fixes, and because the upstream does not release the tests, automated tests, we basically create our own automated tests for the upstream releases, and as and when we find bugs in GTM, we merge those into YottaDB. Those fixes, by the way, are also available to FIS and GTM, but so far they have declined to take our fixes. I just hope that they start taking them because it would be helpful to them and to us. Okay, moving on to Octo. So YottaDB is a NoSQL hierarchical key value database, but we also have SQL. And Octo is basically a SQL database, and the tables, the actual data is stored in the global variable nodes. One clarification, Octo runs on YottaDB on the 64-bit platforms, not the 32-bit platform. Okay, and then Octo is continuously released, which means that at any given time you can install Octo and you get the latest software, and you can continue. You can also continuously update, reinstall Octo on top of what you already have, and that will, pull in the latest Octo. So a big thing that we did this year is the insert, update, delete functionality. Now this applies to SQL tables that are created as SQL tables and doesn't apply to FileMan files which are mapped to SQL tables, for example. Because in the case of FileMan files, you don't just go in and change global variables as you would for a SQL table. But our idea with Octo is that it's not just for analytics and reporting. That's what it was for originally, but it's also a straight SQL database. So if you're using Postgres, MariaDB, or SQL Server, or one of those, you could potentially use Octo instead. And we've slowly been expanding the clients that we support. So now the Microsoft tools, which is Excel and the Power BI, Power BI is a family of a couple of products. So all of those work with Octo. There is a nice GUI called dbeaver, which again I'll be demoing later on in another talk. The SQL Workbench J, and we also have a GUI in our own. There's a Octo and SQL are supported in our own GUI, and Sam will be talking about that later. More recently, we've added support for views, and we also have support for we've also created ARM64 Docker images. So now you can basically run it on an ARM-based Mac, and other things. You can see the slide as well as I can. There are computed columns, and then there are constraints and so on. And all the time we continuously make various performance enhancements. So
Bhaskar, I don't know other people getting the funny buzz now in the audio. Could you try maybe moving your microphone a little bit or something, and we'll see.
Well, I'm actually wearing a headset with a built-in mic.
And Nancy, I heard the buzz when you started talking, but not before.
Okay, that's good, and then I'll shut up. Goodbye.
Okay, yeah, that made the buzz go away, at least for me. Okay, so Sam is going to be doing an Octo update and demo, and it's currently scheduled for Sunday morning, but always check the VistA community meeting schedule for updates because it does evolve continuously. Okay, let me talk a little bit about the GUI. So basically the back end is the YottaDB web server, which again, all of our software is open source. That's where you find it. And there are JavaScript versions that are, JavaScript files are versioned, and we statically serve them from the back end. So, we don't have the sort of the JavaScript framework dependency hell that sometimes can happen if you have a whole bunch of changes, because one framework can pull in another framework, and that can pull in yet another framework, and so on. And the GUI is installed and updated by YottaDB install, just like all of our other tools. So that's essentially our go-to software for installing and updating packages. And some of the changes that we've made in the last year. So now there's a fairly complete set of basic database administration and operations. There's obviously a lot more, but all the basic stuff that you might want to do is now in the GUI. You can view routines and globals, and you can view Octo tables, and you can run SQL queries from the GUI. And some of the latest stuff that we've done is customizing alerts by the region for like when a region gets full. And you may have one region which is primarily read-only data, and for that maybe you just want an alert when the region is 97% full, and maybe there's another region that contains your active data, and then maybe you want your alerts to come from that when it's 80% full. And so that's a recent enhancement, and then there's a whole lot more. So Sam will be doing a demo of the GUI, and he has all the answers to questions that you might have. And again, this is the currently scheduled time for his presentation. Okay, so I talked a little bit about troubleshooting and forensics. So the thing about databases and computer systems is that, when everything is running fine, people are happy. But what happens when things don't run well? And how do you go troubleshoot? And we'd like to make it easier to troubleshoot, because troubleshooting in some cases is like looking for a needle in a haystack. Now, if you think about what a database is, it's a giant state machine. So maybe there's a VistA system that says, okay, we've ordered a brain transplant for Bhaskar, but the question is, how did that brain transplant make it into the order set? And who ordered it? When did they order it? Why did they order it? And all of those state changes in the database are captured by journal files. And of course, the challenge is that the database state changes can actually outnumber the database state. Well, that's not strictly true, but they can certainly outnumber the active database state. And so you have the question of how do you find a needle in a haystack when you're looking for state changes. So, well, since we make a database that's good for storing large amounts of data, the idea came about as to why not take journal files and put the journal files into, load the data in the journal file into a database file. And then why not query that database file with Octo? And so you have the application database file on the left. It creates a series of journal files. And then we have a tool which is included with YottaDB called %YDB journal F. And what that knows how to do is read the journal files and load the data into a database file. And of course, this database file can be potentially large, but you don't actually journal that database file that contains the journal updates, because then you have journal updates for journal updates, and those become huge. And in any case, since you have the journal files themselves, you don't need to journal the database file that's storing them. So you load the journal file content into a database file. And then what %YDB journal F also does is that it exports a DDL for Octo. And now Octo has access to the DDL and the database file, so now you can run SQL queries against the journal file and find out, who actually ordered that brain transplant, when, and why. And that led us to something else, which is that syslogs. So when something goes wrong and when a customer calls in us for support, we usually ask them for syslog extracts. And syslogs can be even bigger than journal files. It can be, they don't have to be. And then the computer is in some sense, a bigger state machine than databases themselves, because computers contain databases. And then you have networks of computers, and sometimes when you're trying to do forensics, you're trying to look at events that happened across computers at a certain time. So this is the stuff that YDB syslog is good for. And again, you can run queries with Octo. And conceptually, what it is you have the syslog. And on Linux systems these days, that's pretty much systemd journal D. And there is a tool called journalctl, which is a standard Linux tool. And what that does is you can export the syslog in a standard export format. So we have a program called YDB syslog, which can take the syslog export format, and it will load that into a database file. And again, it'll put out a DDL for that database file that you can now query with Octo. And by the way, there are, since if you want the complete syslog, what you do is you actually run two of these journalctl syslog, YDB syslog processes. So you first start one that has a follow option that follows updates from the syslog, and then you start one that takes all of the older syslog entries. And you don't worry about duplication because if the same syslog entry is, shows up on both the streams, you just still get only one entry on the database file. So this is something that we've packaged as a plugin, because this is not unlike the YDB journal F, which is, journal files are integral to YottaDB. This is just an optional extra, but it's a small piece of M code, and it's packaged as a plugin, so you can install this with YDB install. And this is basically how it works when you have multiple systems. So if you have a network of systems, you could have a syslog on each one of those systems. So the boxes that have orange lines with purple lettering, that's on the central machine. And on that central machine, of course, it could be monitoring its own syslog. And the boxes which are orange letters with purple outlines, those are remote machines. And what you would do is each of those has its own syslog. You would run journal CTL on those syslogs. And then you use netcat, which is a really handy tool. And it basically sends the syslog over to the host, to the central machine. And you can have YDB syslog instances there that load all of that into the database. And now, again, with the OctoDDL, you can run Octo queries that run across machines. So we actually have that running in-house on, we have a couple dozen servers, and we have one machine on which we're running this. And since we've been running it, which is probably about maybe a month or two ago, the database is about 200 gigabytes. So there's a lot of data. And one of the things that we probably need to do as an enhancement is put in some functionality to purge older data from the database. But anyway, so this is what we have, and I think, yeah, and again, I'm doing a demo on that later today, and then looking ahead to where we're going. So on YottaDB itself, something that there's a library called readline, and so when you use the shell, this is the readline is what has memory between shell sessions. It allows you all of the line editing capabilities and so on. And YottaDB right now has its own basic, inline editing for the direct mode, but it doesn't have any memory beyond the current session. It only remembers the last 99 commands and things like that. So using a standard tool like readline, and by the way, this will be an optional environment variable that sets it up, will allow you to basically have something like shell editing capability for direct mode. And this is something that Sam has been passionate about. He got interested in it long before he became a YottaDB person, and I think it's finally close to being ready to integrate with the code base. So that will be coming. We have in the simple API, as you know, YottaDB is language agnostic, and we have APIs from multiple languages. So we have a simple API function for importing and exporting variables as JSON files. We also have the ability to pass a listening TCP socket between processes. And then we're also, as we integrate the GTM version 7 releases, an individual database file can be 4 times larger. So if you're using a 4 kilobyte block size, today an individual database file can go up to about 4 terabytes. And then you can have something like 2 to the power of 32 different database regions. So this is not the logical database size limit, it's the size limit of an individual database file. So now it goes to 16 terabytes. And to put that in perspective, on an ext4 file system, that 16 terabytes is the file size limit. If you want to go bigger than that, you have to use a file system like XFS. And then we'll continue to improve troubleshooting and forensics. And part of that is also because it makes our lives easier. And you can see all of our software is done out in the open. So when we develop software, the things that we're working on, we have issues created for them, and you can go look at the issues on GitLab for all of our projects, and that'll tell you what we're working on and what we plan to work on. And if you have a wish list for something that you want, you can just put that on, just create an issue for that. Okay, moving on to Octo. The next big thing that will be coming is date and time functionality. And then foreign key constraints is another big thing that we're working on. And that's the URL for looking at what we think is coming down the road on Octo. On the GUI, we're doing real-time monitoring. So one of the interesting things that not many people are aware of is that YottaDB, and this is inherited from the upstream GTM code base, but YottaDB actually lets you monitor individual database activity by individual processes in real time. And we're planning to add that functionality to the GUI so that in real time you can kind of see what's going on. You can see, if there's a runaway process and things like that. And for the basic database functionality, we'll continue to increase depth and breadth, such as replication. And again, there'll just be a bunch of more stuff coming. And there's the URL for looking at GUI issues. And that really is the end of my talk. I'm sorry that I didn't take the entire 45 minutes, or maybe you're glad that I didn't take the entire 45 minutes, but let me stop sharing and open up for any questions or comments.
So it's good you talked fast, but
Okay.
tell me, can you say again what you said, something about SQL and FileMan and Octo, and that got by me too fast. Can you say that
Okay,
again?
so basically for FileMan, with Octo, you can query FileMan files, but you can't, or perhaps I should say you shouldn't try making updates, because FileMan has a whole bunch of rule checking and dependency checking and so on that
Right.
a straight
Okay.
SQL engine would not be able to enforce.
I got you. Okay. Thanks.
And Sam might be able to state this a little bit more clearly than me.
Okay. I'll follow that. Thank you.
All right, that explanation is good enough, and that works. So that's perfect.
Any other questions or comments? I'm glad the conference is virtual because now nobody can throw rotten tomatoes at me.
No rotten tomatoes, Bhaskar, but so later on, are you going to show in your next talk, are you going to actually show this in action?
Yes, I am. Though I'm going to have a demo, but the thing with all live demos is, I do demos the same way that I play pool, which is I call my shots as watch this.
Yep, yep. And my other question, when you were talking about the syslog and being able to use your utilities to better manage that, can you do that across both Linux and Windows as well? Can you accept information from Windows logs?
Well, in theory, yes. In practice, we haven't written that. And even on Linux itself, it's basically just systemd journald. So you would have to extend it to do other types of, like if you wanted to take rsyslog or things like that. But right now, it seems like at least systemd journald is kind of one when it comes to logging.
Okay.
So when you go ahead, I'm sorry, Joe.
No, I'm done.
I was just thinking about, when Linux administrators want to use this um, even if they're not necessarily using running anything on GT, on YottaDB, to is it usable that way? Just as a Linux system administrator to have a database of this stuff.
Well, absolutely. Of course, the database is YottaDB, but yes, absolutely, that is the idea. And in fact, I have a presentation on that scheduled for All Things Open in Raleigh, North Carolina, in I think it's on Monday the 16th, or maybe Tuesday the 17th, but one of those 2 days.
And that's an open conference.
That's an open conference. It's called All Things Open, and you can register for it. You can attend virtually, you can attend in person, and it's a lot of fun. So if anyone is going to be in the Raleigh area, think about attending.
So I was looking at your list, your name in the speakers list, and you might want to learn how to spell YottaDB.
Oh, okay, thank you. I guess I'll fix it.
Typos. They're such a fun addition to life.
Yeah, yeah. And then the other one is when your phone or whatever decides to fix your typo for you. It really does you in.
Oh, yeah, that's true.
All right, let's see who's.
Okay, so
I don't
I
see
guess if there are
Howard.
no questions, if there are no other questions, I'll turn it back to you, Nancy. And maybe this gives people a chance to get a cup of coffee or
Yeah, maybe
whatever.
because I don't
So,
see Howard yet. Let me look and
so
see if he sent me an
Bhaskar,
email.
could you talk a little bit about the cross language stuff that you got in Yotta? I think you mentioned on hard hats that you just added Lua. Is that correct?
That's right. So basically, what we have. So if you take a step back, the power of M is the fact that there's a language and a hierarchical key value database that is tightly integrated with the language. And
Yeah.
and what we decided was that that capability was, that we shouldn't sort of be a dog in the manger and just keep it to the M language. So we created a native C API to the database. So you can actually access the database from C without ever writing a line of M code. And it's as simple as there's a header file with a bunch of defined functions. You include the header file, and now you can write a program that accesses the database, and you can write that program in C. So, and again, so you don't need to do anything about M or anything like that. You just include the header file, you install YottaDB, and you compile the file, and it's good to go. And now, because C is the lingua franca of computing, that C API allows a whole bunch of other languages to have APIs. And some of the APIs are things that we wrote, like the Go wrapper. We call those wrappers. So the Go wrapper is something that we wrote. And David Wixel, I don't know if he's on, but he extended NodeM to use the C API for YottaDB so that you don't have to go through M. And the Lua wrapper was written by University of Antwerp. They are using Lua as as a replacement for. They have a lot of PHP, and they're looking at Lua as an alternative for PHP. So that's how the other languages work. So at this point, if someone needs support for a language, it's a matter of using that language's foreign function interface to call a C library.
Cool. Yeah. So I remember reading something to the effect that the Go language interface had to be have a lot of extra work because Go is such a low-level systems language. Is that true?
Well, it's not quite that Go is such a low-level systems language. If you want a low-level systems language, look at Rust, for which we also have an API. But what Go does is, so the first two letters of Go are also the first two letters of the company behind it. And, they kind of think they own the world. And so what the Go language does is that it, thinks it has control of the entire process. And any other programming language or library that lives within that process needs to play by its rules. And that was kind of a pain in the real estate.
Yeah, I can see that, especially if they think that they can control multitasking.
But Go has a lot of neat features, by the way, things like Go routines. And so, if kind of like the original M, if all you did was sort of go into, boot the computer system, run mumps, and then to exit mumps, you shut down the computer. So if you were doing that in Go, that would be, extremely powerful and capable. It's a great language, and it allows you to write code that is memory safe. What it doesn't do such a good job of is living in an ecosystem with other languages.
Ah, okay. So even for some of the other quote popular languages like Rust or Swift.
Rust, Go is probably a most difficult interface, wrapper to write. So things like Python, I don't know about Swift, but Rust was a fairly straightforward thing. It required, it's a new language, so with any new language, there's always wrinkles that you have to learn. But Rust was fairly straightforward. Python was fairly straightforward, and again, it had its wrinkles, but Python was straightforward. Go was the one that was, I still have scars on my back.
Okay. So now that you've got a Lua interface, and now that you've got Octo handling the SQL, so when are we going to port MediaWiki from their SQL to a Yotta compatible environment?
Well, that's for our ecosystem, and I guess you're leading the ecosystem. So let me know as soon as you have a pull request.
Absolutely, absolutely.